This video is looking at 2015 higher level section A. So the first question here, A1, is a planes question, oblique planes question. So the 3D graphic below shows the display box for chocolate eggs. The drawing below shows the incomplete pictorial, so that's this view, and orthographic projections of a square-based prism. The orthographic view is over here, which has been cut by the oblique plane VTH. On the orthographic projection on the right, complete the plan and elevation of the cut prism. Complete the pictorial drawing projection of the cut prism. And on the orthographic projection on the right, determine the true length of the shorter diagonal of the cut surface. So starting with part A, I'm going to take each point in turn here, so it's going to be projected from the plan up into the elevation, and then we're also taking lines parallel to HT. So this line here is parallel to this one. I'm going to do that from each of the points. And the other two. So taking these points here now, vertically up here and then across to intersect the point directly above the one in plan, so that's giving me this point here. So same point, same idea for this one, horizontally across, intersects the point from plan, which they'd given us that line already. So that gives us this point. We have the point up here at the back, and we have this lower one, so now it's just a matter of joining these points up. And this one here. So we've got hidden detail line for that back corner. There's a visible line for the front edge. I already have that one, and this one then down here as well. So that is the orthographic view completed. To draw the pictorial view, it's essentially doing the same thing, except off over here. So need to take a line this way. They've kind of shown us what we're doing. Taking a line parallel to, again, HT, just like what you did down over here. And do it for the other one as well. Taking a line vertical until it hits VT. So line vertical until it hits VT. And then out again parallel to HT to intersect a line directly above the point. So that's this line here coming out along. That gives me this point here, and for the other one here at the back, that's this point. Again, these are all joined up. And we've got solid line here and here. And that is part B of this question. So now we're going to looking for the, sorry, I didn't complete plan of this. So just darkening in the outline of the plan. So the shorter diagonal is going to be this one coming across here. That is longer than this one. So taking this distance, line along here, that's our diagonal that we're looking for. So this is that same line up here. So what we're going to do is we're going to rotate it around so that it's now looking, we're now looking perpendicular to it. So rotating it in plan, and then we'll see the true length of it in the elevation. So as it'll be horizontal, it's horizontal now here in plan. If something is horizontal in plan, it is a true length in the elevation. So taking the bottom point, projecting this across, and this line here is the true length. Question 8.2 is conics. So the small outline elevation, which is all given, that's this, shows the trophy is based on two identical parabolic curves. So it's not a hyperbola, it's two parabolic curves, AB and CD. Circle shown is tangential to the curves. The drawing on the right shows the incomplete outline elevation of the trophy. V1 and V2 are the vertices of the parabolas, and F1 and F2 are the focal points. So we're asked to draw the parabola showing clearly how to determine the position of B, D, P and Q. So B, D, P and Q. Draw the circle tangential to the curves at P and Q respectively. So we're going to divide the sides here up into a number of equal parts. I'm going to go with 4. That gives us 4 points there. Need to divide this into the same number of sides, but only as far as the focal point. That's where the axis runs through it. We're only working on one side of it at the moment. So again, 4 equal parts. And again, drawing this up to the end of the line. Sliding set squares or adjustable set square if you have them. That gives us these points here. So labeling these points, you got A, which is 0, 1, 2, 3, and 1, 2, 3 coming down this way as well. V is our vertex, so all the lines along this edge here. So our axis runs this way. That line is cut by the axis, so our lines go parallel to the axis from here. And this one here joins the side, these join to the vertex. So joining all these up, so the 2's together, the 3's together, and the 1's together. Drawing these as best we can. That gives us our curve here. I'm going to mirror this onto the other side. So taking 1 point, 2, and 3 should be plenty. Either side of the axis, so point of our compass on the axis measuring to the opposite side. That curve, that point just goes below the line, so I can join these points up now again. That gives us our curve, and this point here, just to the right of that line, is point B. As this has an axis running down through the center of it, we can also mirror across this axis line. So we can mirror, we don't need to do all the constructions again. So just mirror across the axis. And we'll measure point B there. So from the axis down the center to the other side, each point and then finally I'm measuring B, which will give me point D, and to the other side here. So this is point D. And that gives us the parabola on the opposite side. So the final part of this is locating the circle here in the center. So we're looking for points B and D, P and Q. So we have B and D, P and Q are vertically above them. So we can just take these vertically up, because it's that point and this point here. So that's a point. It's going to be tangential to it. So we need to draw the same construction that we would normally draw for a tangent. So as it's a parabola, one focus is near us here. So we can join point P, or sorry, point Q to that point, the focal point, and the other point as the second focal point for the parabola is at infinity. It's a line parallel to the axis. I'm going to bisect this line, or sorry, this angle. Bisecting this angle is going to give me the tangent, or the normal. So this will be the normal that I get. And the center of that circle is going to be out along this normal here somewhere. Where out along it? You can bisect the other side if you want, but there's no point. It's equal distance on either side, so it should be at this point here, where that normal intersects the purple line, the axis through the center. So all we need to do then is point our compass on the point that we found where the normal intersects that axis, and we can draw a circle. And that completes part B of this question, drawing the circle from points P and Q.